Okay, now let's look at this question here. You see that matrix P represents 4 different types of television. Okay, you look at it, this is 4 by 3. Okay, 4 by 3. So, and then they are on sale in each of the 3 shops. So obviously, the vertical column is the 3. There are 3 vertical columns. So this will be shop A, B, C. Okay, now what about the row? You say there are 4 types of different television. So there are 4 rows. Sorry, 4 rows. 1, 2, 3, 4. So let's say the type TV W, X, Y, Z. Okay, let's look this in detail first. What it means is in shop A, you got 30 units of TV W, you got 70 units of TV X, you got 50 units of Y, and 14 units of Z. Then in shop B, you got 25 units of TV W, you got 15 units of TV X. Okay, and then subsequently, that's how you interpret the elements of this matrix. Okay, now Q represent the value of each television in dollars. What it's saying is there are 4 columns here. Okay, so this is A is the price of TV W. Okay, TV W. This is the price of TV types X. 450 is the price of TV for type Y. Okay, so if I want to put a heading for this, it will be type of TV, the column, and then the row will be the price of each TV. If I want to put the heading for P matrix, it will be this is a shop here, this is type of TV. Okay, for the row. Now state without evaluation what is represented by the matrix Q times P. Okay, now so I put Q here, which you have a price as the row and you have a column as the type of TV. Then this P, which you have the row as the type of TV and a column as the type of as the shop A, shop B, shop C. Okay, now let's check whether it can be multiplied. 4 here, 4 here, so this is similar. Okay, so therefore it can be multiplied. Okay, and then what's the resultant matrix? You got a 1 here, you got 3 here. So basically you have 1 row and 3 columns. Now let's check the meaning of the multiplication, see whether it makes sense. Now the price of TVW is 650. If you use the multiplication of matrix, 650 will multiply by 30, 500 will multiply by 70, okay, 450 will multiply by 50. So let's check the logic of the multiplication. The price of WTV 650 time, remember this W is the quantity of TVW in shop A. So if I take 650 times 30, that means it's the total cost of WTV in shop A. Okay, now secondly, if I take type X 500 times this quantity of X 70, the amount will equal to the total cost of type X TV in shop A. Okay, similarly, if I take now 450 times 50, 225 times 50. So in summary, this multiplication will give you 8600. What it means is it will end up as the total cost of TV in shop A. Okay, that's how you look at it. Then you take this cost per unit multiplied by B, the shop B, and this are the quantity. What you get here is the total cost of TV in shop B. Then similarly for column here, taking this multiply by the quantity in shop C, this is the total cost of TV in shop C. Now let's look at the title of the metric. You got a price, type of TV, time, type of TV, the shop is the column. Now remember, when you the resultant metric is you take the row, which is the price, okay, and then the column you take upon the second metric, which is the shop, okay. So the resultant metric will be the shop, which is the column, the title of the column, shop ABC, and then the row title will be the price, okay. So what you get here, basically, this is the price of TV, the total price of TV in shop A, total price of TV in shop B, total price shop B, shop C, okay. Now this is how you work out. Remember, when you do the multiplication, type of TV, okay, this W, so they must tally. This is quantity of W, this is price of W, this is price of W, okay, make sure they match, okay. Then this quantity of X, this is price of, make sure you do this checking when you do the multiplication, okay, then it becomes a valid multiplication, okay. So you see, it's so important that you use the orders of the metric to determine the resultant matrix. And then after that, remember, you take the heading of the row from the first metric and put here, and take the heading of the column and put over here. This is the resultant. This is a description of the metric, the resultant matrix. Okay. Now the next one is asking you what is represented by QPR. QPR is Q times P times R, but QP we already work it out. This is the price of each of the shop. Here each of the shop, the total cost of TV in each of the shop A, shop B, shop C. Now if I multiply by 111, okay, let's look at the order. 1 times 3 is 3 times 1. Finally, what I get is 1 times 1. So this is basically 86 times 1 plus 4625 times 1 plus 11265 times 1. Add together. What do you think of this total, this number represent? Okay, but obviously we know this is the total cost of TV in all the three shops. Okay, this is combined cost of TV in all the three shops. That's it. Okay.